Last note on graphing: when we're analyzing position versus time graphs, the slope of the line will give us some information. Recall earlier that the slope was used to describe the motion. The slope of a position versus time graph is the change in location per change in time, which is the velocity. So this slope is equal to the velocity on a position versus time graph. If we look at three graphs, this is an object that experiences a positive displacement. So if we look, our starting location is here, our ending location is there, our displacement, or our delta x, is in the positive direction, it's increasing in this graph, and that will have a positive constant velocity. In this case, our initial location is there, our final location is there, our displacement is negative in sign. When we have a negative displacement, we have a negative slope or a negative velocity, and here our initial and final locations are the same. Therefore, there is no displacement. If there's no displacement, the velocity is zero. So a positive velocity means an object is moving in the positive direction, and negative velocity means you're moving in the negative direction, and a zero velocity means there's no displacement whatsoever. We can use these position versus time graphs to make computations of motion. So we can describe in words what's happening to the velocity of these objects. If we look at the first object, the blue object, car 1, car 1 maintains the same value for location as time goes on. So its velocity is 0. Let's take a look at the initial location for car 3. It starts off at -5 and ends up at about +15. Its displacement is positive. If its displacement is positive, its velocity is greater than 0. Car 3 starts off with a location of about +10 meters and ends up with a location of -10. Its displacement is negative. Its delta x is negative. Its velocity is negative. Its velocity is less than 0. So again, this is a positive slope, a positive velocity. The red car has a negative slope, a negative velocity, and the blue car has 0 slope, a 0 velocity. Alright, in this slide what we're going to do is draw the axis of a velocity versus time graph for each of the cars. There are 3 cars in this presentation: blue, red, and green, and we're given a displacement versus time graph, or it's a location versus time graph. If you look, this location is 0, and the blue car starts off at +10, ends up at +10. It has no change in location. So if we were to plot the displacement of the blue car versus time and end up with a flat line like we have here, its velocity is not changing as time progresses. So we'll draw a line that falls on the 0, and that is not changing. If we come up and change our color to the green, we can see that this green car starts off on the -5 mark and ends up on the +5 mark. That displacement is positive, therefore the velocity is positive. So we have a displacement of from -5 to +15. We have +20 displacement. So we'll come down here. Velocity is displacement divided by the time interval through which it occurred, the displacement. So we have +20 meters per how many seconds? 5 seconds in this journey. So this velocity is positive and constant because we have a straight line, 1, 2, 3, 4, if you will. And we'll draw a line like so. The last graph, or the last car, it starts off at +10 meters and ends up at -10. This displacement is in the negative direction. The delta x is negative, so the velocity will be negative. So we'll draw velocity is displacement per unit time. And the result from this is negative 20 meters of displacement, which is interpreted from the graph, divided by 5 seconds. That will give us a velocity of negative 4 meters per second. So if we look at the answers,